Okay, then we move on to negative autocorrelation d-test. Okay, this is the graphical sketch area that helps you to make the right decision. This time we use the right hand side actually. Okay, so these are the decision rules. Okay, so again you have to first look for dl du, then you work out 4 minus dl 4 minus du, then it depends on the location of the computed d-stat, then you decide whether you do not reject H0, or you end up having an I don't know outcome. Okay, and then we can do 3 questions. Okay, question 4. Okay, multivariate regression, sample size is 10, K prime 2, alpha 5%, computed d-stat must be given 3.575. You can already see this computed d-stat is quite close to 4, so it already implies most likely there is significant negative autocorrelation present in this regression. So null hypothesis, insignificant negative autocorrelation. Alternative hypothesis, significant negative autocorrelation. And again, our aim is that we do not want to reject the null hypothesis. Computed d-stat given. Now we have to look for dl and du, 10, 2, 5%. Yeah, 5%. I must use the right table. Yeah, 5%. K prime is 2. Sample size is 10. Therefore, dl 0.697, du 1.641. Okay, yes. And then you also work out 4 minus dl and 4 minus du. So you see the 4 answers here. And then my computed d statistic lies in the rejection region because it is smaller than 4 but greater than 4 minus dl. Therefore, null hypothesis is rejected. And then bad news, it means the alternative hypothesis will take place. That is, there is significant negative autocorrelation. Okay, happy with the first one? I mean, question 4. Question 5. Okay. 3 explanatory variables, sample size 30K prime, number of parameters excluding the B1 hat constant is 3, alpha is 5%, computed d-stat given 2.555. So 33, 5%. K prime is 3, sample size is 30. So dl should be 1.214, du 1.650. Okay. Yes, 1.214, 1.650, then you can easily work out 4 minus dl and 4 minus du, and this is the conclusion from the graphical sketch. My computed d-stat 2.555 is greater than 4 minus du, but smaller than 4 minus dl, so it lies in the I don't know region. Therefore, we are uncertain, undecided if significant negative autocorrelation is present in this regression. So the answer is I don't know. Okay. And then for the last one, okay, question 6. Okay, sample size is 35, K prime is 4, alpha is 1%, computed d-stat is given 35, 4, 1%, so I must use the other d table. Alpha is 1%. 35, K prime is 4, so 1.028 and 1.512, okay? Yes, 1.028, 1.512, then you can easily work out 4 minus dl and 4 minus du. By the way, do you notice the computed d-stat 2.450 is quite close to 2? Then it already implies good news. Then it means it suggests most likely the negative autocorrelation in this regression is quite weak or insignificant. And then indeed, from the graphical sketch, we can confirm our suspicion as true because my computed d-stat is greater than du, but smaller than 4 minus du. So it lies in the do not reject H0 region. Therefore, H0 is not rejected. then good news. So it means from a statistical point of view, null hypothesis is more likely to happen, meaning there is insignificant negative autocorrelation. Okay. And then the last part is the remedy, which is the GLS, generalized least square. And then I can make use of this table to aid the explanation. Okay, so this is the original regression, and then y as a function of x, and then I assume there is significant, let's say, positive autocorrelation, because by running the regression, residuals lag as a function of residual lag by one period, we derive the autocorrelation coefficient rho hat as 0.9, which is very close to +1. Therefore, we need to do some transformation. We have to derive x asterisk and y asterisk. So let's go to the actual data. I just want to simplify matter that only 5 observations. And then x and y, and then this is the transform x asterisk equation, which is equal to x at time t minus autocorrelation coefficient times x value in the previous period, and then that explain the calculation. Okay, 4 minus 3 my x in the previous period times autocorrelation coefficient 0.9. This is why I get 1.3. One more, x at time t, which is 5 minus x at the previous period, 4 times autocorrelation coefficient 0.9. This is why I get 1.4. And then similar explanation applies for the y asterisk, the transform y, which is equal to y at time t, let's say 6 here, minus y in the previous period, which is 2 times the autocorrelation coefficient 0.9. This is why you get 4.2 here. Then you complete the column, and then you run the transform regression y asterisk as a function of x asterisk. And it is argued that by running this transform regression using the transform x and transform y, we can finally get rid of autocorrelation. Okay. And then to conclude, there is a nice exercise for you to do. I think it is exercise 8. I think exercise 8. Let me just double check. I think it is exercise 8. There is a table for you to complete to summarize the last chapters 10 to 12. Let me just double check. Yeah, it is question exercise 8, question 1. Okay. These 3 chapters, the 4 areas: definition, consequences, detection, and remedies. And then from the study guide, I actually gave you the suggested answers. Let me delete this redundant table. Okay, this is the one. Definition. Okay, chapter 10, you need to understand perfect collinearity, perfect multicollinearity, imperfect collinearity, and imperfect multicollinearity. Heteroskedasticity, you need to know the general definition. You need to know that it is more likely to happen in cross-sectional data. And in case the question I allocate quite a high number of marks when I ask you to define the concept, you better also tell me the difference between pure and impure heteroskedasticity. And then the same for autocorrelation, general definition. You need to know it is more likely to happen in time series data, and then the pure and impure case of autocorrelation. Okay, consequences, and then I give you some suggestion to memorize these consequences easier. So let me just stop here, and then I want you to look at the suggested answers for 1 minute, just to compare the 3 columns. Okay. Detection, okay. It is easier for the chapter 10, okay. You don't really need to use any statistical table. Okay, I think the most so-called difficult one would be VIF, variance inflation factor. And then for chapter 11, the 3 tests you learn are Park test, which only works for bivariate regression, two-sided t-test, Spearman's rank correlation coefficient, also for bivariate regression only, two-sided t-test, and then y-test, which works for bivariate and multivariate regression. But if I ask question on y-test, I would mainly focus on multivariate regression. And then autocorrelation, you learn the runs test, Bruce-Godfrey test, and the Durbin-Watson d-test. And then finally, the remedies. So don't get confused between weighted least square and generalized least square. And the remedies are much more detailed. Yeah, there are many, or I would say there are more remedies when it comes to multicollinearity chapter. And remember my suggestion to ask you to group the first two as a pair, and then the third and the fourth one together, and then finally the last two together. And it will be relatively easier to remember the remedies. And remember, when it comes to the remedies, you can't just name the remedy. You need to provide additional information. You need to refer back to the given regression information. Okay, so I think we actually finished chapter 12 now. Then we have to move on to the last chapter, chapter 13, which is the longest chapter, actually.